you should be able to do it. All right. Does
Okay.
everybody see the red recording button up there on the left? Recording is
Yep.
in progress.
All right, I got it. It's working now.
Cool.
Izzy says she can't hear you though.
Huh.
Can she hear others? It's just me, or can she hear nobody?
Let me see.
A chat.
Can you guys hear me at all?
I can
I
hear
hear
you.
you.
Yep.
Okay, I am having trouble hearing you guys, so I think I might exit and rejoin because I
Okay.
don't think that my audio is bad. So I'll be right back.
All right.
Okay.
All right. I guess I should be here in a second. We were.
Are you, Isabel, are you connected to Wi-Fi or through?
Yeah, I still can't hear.
Are you Wi-Fi
Hold on, let
connection?
me try and fix my audio settings again.
Is there a, so that's what I did yesterday. Is there a separate, when you do Zoom, is there a separate
Not sure what is happening because all my output
There is
settings are
on
right.
audio. So what I have on mine, right? I have different choices as to what I'm using as my audio. So if I click on the microphone, I'm using the microphone that's on my webcam and this time, but I actually have I have choices there. So if that's set wrong, and it's also the same thing with speakers. Like one thing is that you can hear us. If you can hear us, excuse me, if you can hear us, but we can't hear you, then it's a microphone thing. If you can't hear us, then it's a speaker thing, right? And you can do this test speaker and microphone stuff too at the bottom. It can be, and sometimes there's other software that you can have running that fights with this stuff sometimes. So I've had that happen before too. Like green screen kind of software stuff. I had some stuff that was not very compatible with this. Can you hear us at all, Isabel?
I don't think she can.
should
She was the one that called for she wanted a meeting and I kind of said, hey, it should be a group meeting. So we it's kind of important to cover in this thing. We could,
we all got together yesterday and I have a few questions that we came up with, I guess, in the meantime, while she figures it out, unless you want to just give her another minute.
We could, if you wanted to reconvene at 2:15, if you guys have the time, we could, or 2:20 or something, we could reconvene then,
Okay.
while she figures this out.
That's fine with
Are
me.
you guys in like email contact with her?
Yeah, we're on Discord with her and she's saying she's trying everything.
Okay. It could be, I'm trying to decide if Discord could, well, you have Discord too, so it should be fine. Yeah. I don't know.
I did the same thing yesterday and I had like the speech to text speaker selected and it took me like 20 minutes to figure it out.
Right. Yeah, so let's reconvene at what time? 2:20? Do you think that's
2:20?
Yeah,
okay.
that works.
Or I'll be checking my email. So if you get it working, just send me an email and then we can just go right back on again.
I just got it figured out.
Oh,
okay, cool. All right.
Sorry
Nothing
about
like a
that.
little bit of a threat, right? Okay.
Right.
All right. Okay, so what are the questions?
Okay. All right, here, let me pull it up. All right, so I guess the first one was the format for turning in the thing. Did you want 3 separate PDFs for everything or 2?
One document, right? But it has different parts. So,
Okay.
so if you think about it, if this was at scale, like if we said, I want to do this for Java, and it's not necessarily an even division into 3 parts, right? So the main part in Java would be the BNF, obviously. But if I had a team, right, I would say, if you guys were my team, I would say, Isabel, I want you to work on the regular expressions. Do you go by Isabel or do you go by Izzy or what?
Izzy.
Izzy, okay. My daughter is Isabella, and we first started calling her Izzy, and then but she's Bella. So anyway.
Oh, okay.
All right, so
Very
Izzy,
nice.
okay, so I might say, Izzy, you're responsible for writing all the regular expressions for Java, and that includes all of the keywords and symbols, right? And so that'll be a list of, like, in Java, that would be like a list of 100 things, right? It's fairly substantial. And I say, like, you produce that document. And then I might say, Jacob, I want you to do the precedence and associativity to figure out for all of the operators, including the bitwise operators, everything. I want a table that has, left associative, right associative, order of precedence. I want that full table. And then I'm going to say, okay, Mark, you and we're going to work on the BNF grammar part. So I'm not saying you should do it this way, but you should think of that's kind of how it goes apart. And so if we implement the BNF grammar right, but nevertheless our expression grammar has the wrong precedence, we're going to go knock on Jacob's door and say, dude, man, you gave us the wrong stuff here. Right. And it's sort of an accountability. It's a traceability thing, right? So it's like, where was the error? Where did it start? Was the precedence and associativity table correct? And was the BNF people the ones that got it wrong? Or was it the other way around, or both? Maybe it's both, right? I literally had another true story from Sandia Labs. We were working on some embedded software, and they were doing a tester for it. And they had a Boolean tester, and it had 2 errors in it. So it turned a false to true and true to false. So everything was okay on the tests, right? So it is possible to have 2 errors, right, on both sides. But anyway, so that's the spirit of the document, right? And for example, when it comes to milestone 3, there are going to be 2 things that you need to type in. The lexer, somebody needs to type in all of the regular expression stuff into the lexer, and somebody else or some other subgroup needs to, or everybody together or whatever, needs to type in the BNF grammar. Now, the BNF grammar is fairly a straightforward mapping, right? So you take what you do in this milestone, and you pretty much type it in with a little bit of extra stuff. So that's it's easily checked whether those 2 things are equivalent, right? The lexer, much harder. It's very cut and paste, but it's completely cryptic. And not only that, on the lexer, if you get something wrong, you get like no feedback, none, right? It's hitting. It's like segmentation fault in the old C days, right? So you get nothing. And so even though it's fairly easy, it has to be right? So it's a different level of what you have to do to make sure it works, right? And so anyway, so think of like, how are we going to build this down the road? How are we going to do this kind of stuff? And so you have things like this, right? And so within the grammar itself, right, you can break that into 2 parts. I would recommend. One of them is there's the statement level stuff, and there's the expression level stuff. So for us, an expression is everything that can occur on the right-hand side of an assignment statement. And the assignment operator is not an expression operator. I know that it is in many languages, and in pretty much all languages, they say it's a mistake. So this is one of those QWERTY keyboard legacy things that are just bad ideas. So if you look at Java, they say that the assignment operator is assignments can occur within expressions. And then the problem with stuff like this is, right, if you now go look at Java secure coding guidelines, how to write secure code, without exception, there's universal agreement, never ever do this, never do it. And so what we're going to do, since we get to design our language, we're going to say, we're not taking you on your honor. We're going to make it so that you cannot do this. The language will not let you do this, right? That's the best way to avoid a mistake, is to make it not possible to make that mistake. So the assignment operator is a statement level operator, and everything, and then the expression ones are arithmetic expressions and Boolean expressions and all that kind of stuff, right? And one thing that I would like to point out, the pre and post increment operator occur both as a statement level thing and as an expression level thing. And that's nasty. And I put it in there on purpose because if I hadn't done this, you'd think programming languages are friendlier than they really are. So this is it's a bad idea to have this. And let me just tell you why. I'll show you. So if I write something like this, and let's just assume that X and Y are declared and all that kind of stuff. So this is just a program fragment. And now I say print Y. What do I get?
Uh, 11.
So 11 is the sensible answer. Another answer could be 10. And in C++, the answer is undefined. Undefined. If you look up the semantics of C++, it'll say this is undefined. And what that means is that a compiler can do it any way they want. It can give you a 10, it can give you 11, it's all good. And so we actually, back when I used to teach this class in person, we had somebody that tested this. So they used the GNU compiler and the Microsoft compiler, and one of them gave you 10 and the other one gave you 11. So very real stuff, right? This is not like I'm imagining this is some esoteric abstract thing. This is real. And so it is ugly. The idea of having a side effect in the evaluation of an expression is not good. But languages have it, including Java. And so I don't want this. I do want the programming language that we design to have some real side. It can't be completely artificial, right? And so I do require that this pre and post stuff can occur both as a statement and as an expression. But anyway, so that's sort of the motivation for all of this stuff. And yeah, it's ugly, and the world would be a much nicer place if that wasn't the case, right? And if you look at pure functional programming languages, they the evaluation of an expression has no side effects if you look at pure ones. And the reason why that's so awesome is because concurrent programming, just you get it for free magically, right? So one of the gods of functional programming, the guy that was the inventor of Erlang, it says Joe Armstrong or something, he basically said, and he says it a little too much, but he basically said, if you add 10 processors to functional programming, the program runs 10 times faster. That's an overstatement, right? But the reason why, just so you know, right, the reason why Java 8 added lambda expressions. So lambda expressions are functions, are the foundation of functional programming, lambda calculus, right? So lambda expressions are that. And Java did a very bad job, in my opinion, doing this. But the reason why they did it, if you Google it, is so that you can have the benefits of this kind of functional concurrent evaluation. Because of that, so that the programs run faster. Because if you have, there's two kinds of concurrency, right? One is message passing, which is this functional stuff, and the other one is shared state. And shared state is side effects. This is this X++ stuff, right? So imperative programming languages achieve computation by making state changes to program state. That's how they compute, right? The assignment x equals x plus 5, right? That's not a mathematical thing. If it was equality, that's not true ever, right? It's mathematical impossibility. So it's talking about time, before a value of x at one time, a value of x at another time. And so if you want to do multi-core processing, you need this message passing. You do not want shared state stuff. So it's real. And so if I say this because in the lectures, the first time we take a pass at evaluating expressions, I say, assume a beautiful world where the evaluation of an expression was just a value. There was no side effects. Look at how nice all this stuff is. And then I say, okay, now that you've had the taste of ambrosia, now let's get down to the real world about how things really are. And in imperative programming languages, the evaluation of an expression typically can cause side effects. So I'm going to add that to it. And in our project, the evaluation of expressions have side effects. So that first pass that I did on just expressions does not apply to our milestone. It's just sort of showing you how nice the world would be if, right? All right, anything else?
Yeah, I kind of had a question about the regular expressions again. So in your regular expression lecture, you said that like BNF grammars are like trees, right? And the regular expressions are like flat.
Yes.
And so like some examples of like the regular expressions that you gave would be like integers. You'd use regular expressions to describe integers.
Yes.
So can you give me like a couple more of those examples of like something else that you would use to describe
For regular expressions?
Yes.
So for programming languages, for the most part, it's fairly straightforward conceptually, right? So we want all reserved symbols, all keywords and stuff like this, like what. Those are expressions. And the regular expression that defines the set that contains the string if is literally if, right? So those are the really easy ones. And then there are other kinds of regular expressions that define sets of multiple things. And integers is one of those, right? And so is identifiers. So we have identifiers in our world. We have identifiers, integers. Those are, let's call those complex regular expressions, yeah? And then we have trivial regular expressions, which are things like you literally are what you are, like if. So you have trivial regular expressions, so all keywords, all of that kind of stuff. Non-trivial regular expressions that are identifiers and integers. And then you have a little bit of choice on Boolean values, true or false. Those could either be trivial, true, two of them, one for true and one for false, or you could have a non-trivial regular expression that defines the set that contains those two things, right? But
Okay.
since Boolean is finite, that's not a tricky one. But integers, for example, you couldn't just list all the integers, so that's not. So you must use a non-trivial regular expression to describe that set. Now, if you want, so that's for our project. If you wanted to talk about where are regular expressions used in other languages, if you think about floating point, right? So Java has a bunch of different floating point representations. Those you would define, you'd have to look at exactly, it isn't automatically always a regular expression. You'd have to, but basically it would be those kinds of things. Those would be regular expressions as well. Floating points, hex numbers, all of that kind of stuff.
Okay, thank you.
You're welcome.
I had a question about the operators that we're supposed to implement. So you had greater than and equal to, but are we also supposed to have normal greater than and equal, like the greater than equal to operator?
Oh, yeah, you can, it's your language. At the end of the day, right there, this is one of those like homework 2 problem 1 type things. If I just have you implement, let's say less than as one operator and equal to as another operator, can you capture all of the other stuff that you need to say? And the answer is yes, I can always capture the semantics of the other operators, or you could just add them to your language directly, right? So it's not hard to add them to your language, right? So what ends up, what I'm going to do, so I leave that up to you, but just really quick, since this is, I think, a nice example, right? In the same way that this first question in the homework assignment was, show how you can simulate this behavior. If I have something that says if X is greater than Y, this is a concrete example that I'm giving you here, right? And I'm using, so I'm being informal about this, and so we can talk about generalizing this if you want, but I don't think it's needed for sort of showing the point. I could, if I said in my programming language I only had less than, sorry, and I only had less than I had equal to, do something that's equivalent, I would say, well, the way to do this, right, is I take, I flip it around, this kind of thing, right? So I could say, technically, I really don't need this. I could translate code and have the exact same result by just flipping the order of things. And if this isn't, and if I have this, right, I can do, or, this kind of stuff. So yeah, so have I convinced you that you really only need a small set of these things? And so then this is where the difference between, I can decide that, no, I actually want these. They're not hard to add, and I want them. And then the question is, well, why would you want it? And then, well, one answer is, well, it makes writing code easier, right? I mean, that's the point. And in milestone 3, what I will give you is a funky Java program, right, that computes something. And so what I want you to do is to translate that computation that's in that program into your language, right? So, Java has all this stuff with class and all import system, output and all this kind of stuff. We don't care about any of that stuff. All that I want is, what is the calculation that does this, sort of, in some sense, the body of main, right? And so translate that computation into your programming language, and that stuff will have things like this in it, right? And so it may be beneficial to you to say, like, hey, maybe I should have implemented some of these other things to make it easier for me to manually translate my code into that stuff. Yeah. So, but I leave it up to you on whether you want to do it or not. But if it's low hanging fruit, I would add the other operators, but it's not required.
Okay. And then I guess white space.
Right. Okay. So white space is handled at the lexer level. So the way Lexer works, right, is you give it a set of regular expressions, and those regular expressions could be things like try to match the keyword if, or try to match an integer, which is not in quotes, right? An integer is some larger regular expression. So you give it these regular expressions in order, okay? And what it does is it will try to match the largest string using the first rule that matches it. So for example, if you put integer, the regular expression for integer, as the first rule in that list, it will match all the keywords. When it says if, it'll go like, is that the definition of an integer? Alpha followed by alphanumeric. Yes. Okay. I found an integer. Sorry, I found an identifier. It'll tell you, right? So you have to put identifier at the end. right? So you have all of these things, but in that list of rules, what you also have is one rule that says grab white space and throw it away. And I give you that. So that's not something that you have to worry about. But what ends up happening, right, is it says grab the next token on the, is it a keyword, is it an integer, is it an identifier, whatever. And if I find it, grab it and give it back, and then throw away all the white space that you see, new lines, everything, right? Throw all of that away, find the next one, grab that one, throw all the white space away again, find the next one. So that's why you have this, they're very friendly about how many blank lines you have and how much space you have between things.
Okay, is there like this simple way to put in white space? Like, I think I did it right in like, we did it right in like 2 lines, like just putting it in between our statement and statement list.
So that's the super hard. So it ends up being, if you say, this is a real problem, right? So what parsers would like to do, people that allow you to do analysis of source code and stuff, they'd like to be able to preserve comments in the parse tree, right? And so the problem is that technically I can put a comment anywhere between any 2 tokens. I can say, it's a fascinating problem, actually. You have, in Java, right? You can remind me if I'm right about this. I can put a comment here like this. This is a comment, yes?
Yep.
So I can write something like this. Yeah.
Yeah.
And the only way that you would capture this in a program is that these things go here, but comments can also be empty. So now you have epsilon, and then the whole thing is ambiguous. So you can't quite, you can do a little bit of this. There's some hacks that people do, and I've done some of this too, but you can't generally solve this problem. You have to sort of approximate some of this stuff. And because a comment could be here, right? It could be at the beginning of a statement, it could be at the end of a statement, it could be between statements, or not, or epsilon, right? I can have multiple comments. I can have a list of comments, right? So between any 2 tokens, I can have a list of 0 or more comments, right? So it gets completely out of hand very quickly. So you can't at the BNF level in any realistic way try to capture that. So what you have, right, is you have the lexer basically throws comments away as well. So it says the lexer eats white space and the lexer eats comments and throws them away. So it filters them out, right? And so the only thing that the lexer hands to the parser is the tokens themselves, like keywords, identifiers, numbers, that kind of stuff. So those are the bricks that it sends over to the parser, and the parser goes, oh, you got those bricks. Okay, I'm going to build them together this way. Good?
Yep.
All right. Anything else?
I think I'm good.
Yeah, I don't think I have anything else either.
Okay, cool. Jacob?
I think I'm good as well. I didn't have any specific questions. I just came to soak up some knowledge.
Okay, all right. Sounds good. All right, so then are we adjourned for now?
Yes.
Cool. Awesome. All right.
Awesome.
Peace out.
Thank you for your time.
Thank
Bye.
you.
Thank you.
You're welcome. Take care.